Good morning, students. Today we are going to see the experiment number 2. Create a create and rotate a triangle about the origin and a fixed point. Students can refer the textbook Computer Graphics with OpenGL, Horn and Baker, and Interactive Computer Graphics a top-down approach with OpenGL, Edward Angel. Now, first we will see the output of the program, then we will try to understand the concept. So, this is the actual output. So, in this program, this triangle has to be rotated around the origin. Now it is rotating around the origin, and the second option is it is rotating about this fixed point and stop rotation. Now we'll see the program. First we will discuss the concept of the program. So in this program we are using three functions: GL translate with positive value, GL translate with negative value. So these are X, Y, Z. When you are translating a 3D object, X value will be given, Z value will be given. So here we have only 2D, so we have only X and Y value. The next function is GL rotate F. There are 4 parameters we have: theta, that is the rotation angle, X, Y, Z. So the rotation will happen along with either X or Y or Z. So here in our program, triangle is rotating about Z axis, so we will set to 1. Now we will see the basic of rotation. You can see this diagram. There is a point XY, and the point XY is along with an angle pi. Now the point is rotated. So the point is rotated like this. So from XY, it is rotated to a new place X dash Y dash. So this is the rotation angle, extra angle theta has happened. So this can happen with this formula. So this is an example of rotating a point along with origin. So you can see two-dimensional rotation equation about the origin can be expressed in the matrix form like this. So this is the rotated point X dash Y dash, and this is the previous point X, Y. Just you multiply the rotation matrix with the point, you will get the rotated point. So here R theta. This R theta is nothing but a 3 cross 3 matrix. This is a rotation about Z axis. Now in this program we are performing two operations. So the rotation about origin has been explained here. So you take the previous point, multiply with rotation matrix, you will get the rotated point. But this diagram shows little different. Here also same rotation is happening. Point P is rotated to a new location P dash, but this rotation is happening about an arbitrary point, or you say a pivot point. But this matrix is applicable for an origin. So in this case what to do? So we are doing these three operations. First, this point will be translated to the origin. About origin it will be rotated, then again it is translated back to the previous place. So that explanation is given here. First translate, then rotate, again do the negative translation. You can see the diagram. This is the triangle, this is the arbitrary point. So the triangle is translated to the origin here. About origin it is rotated by multiplying with rotation matrix, again translated back to the previous place. And the final operations are given here, that is translation matrix, rotation matrix and the negative translation matrix. So all these three matrices are multiplied. The composite transformation matrix is written here. So whenever you are calling negative translation, this matrix will be called and multiply with the object matrix. And few more functions we are using in second program, menu. So this function is creating a menu, create menu, rotate menu is the name of the menu. We are adding these three menu entries. So glut add menu entry, rotate around origin, around fixed point, stop rotation. So whenever user select these options, the value will be passed 1, 2, 3. So this menu will be attached to right button. And one more function we are using, that is GL load identity. So this is just replacing your current matrix with the identity matrix. Students knows the identity matrix, diagonal is 1. So this will be multiplied with the projection matrix.